Hi there, welcome back. My name is Steve, in case you're new, and I'm working on making a racing game with Unity. In the past week, I've been working on learning the C# job system and rewriting some of my AI code. Basically rewriting an entire traffic system, in a sense. So let me just go ahead and launch the build that I created. So in the first test before I started this project, I probably had about a limit of 100 cars in the scene at once, and right now you're looking at a scene that has about 700 cars spawned into it. And yeah, I'm running pretty close to 60 frames per second. So right now this is all just C# job system. I haven't really tapped into the ECS side of the dots framework yet, but I'm pretty happy with the results. I think that from where I was before, just having a limit of 100 AI traffic vehicles, that was going to be hard to do with an open world game. But I think being able to scale it up to this 700, and I still have room for optimization, and I still haven't even touched ECS yet. So with that in mind, I'm pretty sure I can take this much farther than where it is right now. But at the same time, I kind of feel like it might be good enough, and I could use some object pooling to figure out how to move the cars around based on where the player is, etc. I could do some logical stuff to fix that. But anyway, I just wanted to give you an update because it's been about a week since I decided to start on this process, and I finally feel like I'm at a point where it's working pretty well. So yeah, it feels really good to look at 700 cars just driving around, and yeah, that's a traffic system to me. So let me go ahead and close this, and here we are in the Unity editor. So basically what I did to do this, I wrote this AI job controller, car AI job controller, and really it's only for traffic. I don't want the actual racer AI cars to use this system. What I did throughout this process was remove some of the functions and features from the AI car that aren't really needed for traffic vehicles. Really, they're just background vehicles and obstacles for the player car. I don't need them to do anything crazy. So I went through a process of rewriting all of the MonoBehaviour based logic into this job controller. So now the AI cars, basically when they're spawned into the scene, what they do is they register with this job controller, and then it populates all of these fields. You can see I have 682 cars. So this FPS counter that I'm using in the editor, it's not really as accurate. The Unity window seems to be more accurate. But basically this simulation is running about 60 frames per second. So like I said, what's happening is all of these cars come into the scene, and then they register with this AI job controller, and this job controller basically it'll run some logic in a standard update loop, and then the rest of the logic is whatever I was able to push through the job system is going through there. You can't really push rigid bodies into the job system. Anything that's a class you can't put in there, so you could only really work with structs and non-nullable data types. So it was a little bit of a learning curve, and there were some scenarios where I had to figure some things out, but I feel like going through that process over this last week, I feel like it really paid off. You might notice there's some cars that are colliding at the intersections and causing a traffic jam, but that'll be fixed in due time. Better traffic management. But anyway, overall, this is where I'm at, and I'm pretty happy with the results. I think 700 cars is awesome. I definitely am curious what would happen if I introduce ECS to this mix. At this point, all of the logic is basically, it's inside of this one script, and this script is operating on all of the AI vehicles that are in the scene. I'm going to pop open Visual Studio just so I can kind of show you what I'm doing. And this is probably, like, I'm not an expert in this. I'm still just learning this, but I'll try to break down what I did to transfer the logic to this system. Let me zoom in a little bit. So basically what's happening here is I still haven't set up the gizmos yet, so that gizmo code is just commented out, but this controller will also be responsible for the gizmos. Basically, I created this AI job controller class and just populated it with all of the different variables that I need. So like the references to all of the front right wheels, front left wheels, the colliders, anything that I'm using for this system. And in that, I've been trying to optimize and figure out what type of data is unnecessary, basically just consolidating and iterating through the code until it was a little bit cleaner. So I have a ton of variables, obviously, and I'd like to clean that up a little bit more. So what happens when a car is spawned in? It basically calls this register car AI function, and it passes in its car AI reference. And at this point, the car AI reference, or the car AI script, is pretty slim. It's only 60 lines, and it is really just calling register car when it's spawned and on reach waypoint. So it has when it collides with a waypoint, this is all the information that it will send to the job controller. And then it has a start driving and a stop driving function. So I could, and those actually also call into the job controller. So when this register car is called, it actually returns the assigned index for the job controller, and that's how I'm able to still have some control over this car AI traffic script. So basically it calls into register car AI, and then I iterate through, and at this point I go through and I allocate all of the native arrays, and I configure whatever data needs to be assigned. And then once all of this data is set up for each vehicle, and each vehicle spawned, this is an instance as well. So once it's done with the awake portion of the code, then it just goes into an initialize coroutine. And at that point, I think I had to put this wait for a second because for some reason some of the data wasn't there. And this is an example of one of the pieces that I still need to optimize. So like I'm going into the waypoint route list, and then I'm going into the waypoint data list for that route, and then I'm grabbing the transform. I really need to just make a list that holds that transform and figure out the logic to gather that transform. And then once the route point position is assigned, then all of the AI cars are told to start driving. And then I have a few different helper methods, and these really just call into like the index of a list and assign new data. And for the most part, that is all used with on reach waypoint. So when a waypoint is reached, that car just calls into these methods to update the variables. And then from there, I'm basically doing a fixed update. I've tried to figure this out. I really want to iterate over the list as little as possible, but I still have to figure out how I wish I could set up a callback or something. I don't know. I got to think about this a little bit more, but basically the waypoint routes hold the variable for if the first vehicle at that traffic light should be stopping. I need to figure out how to get that into this list of collections without having to iterate through this for loop. And then after that, I'm just basically, I have one big job. I'd like to separate them into smaller jobs over time. But first, I'm just trying to get it all into this data structure and then work through optimization. So this job is basically assigning a ton of data. And then it calls the schedule for that job. And if we go up to this first job, it's really a generic name, car AI controller job. But what it's doing is I have the route progress logic in here, and I can probably come in here and clean this up a little bit more. I have the check if lost progress, which for the most part, that's not even used on AI cars. It is if they get stuck, but that's about it. So maybe this is logic that I can probably omit from the system, and just come up with something that doesn't need to go through this. But anyway, that's in the job, so it's not really, it's not as troublesome as it was before. And then the route logic I'm not actually doing here. I'm still doing that in the fixed loop. I don't remember why. I think I just need to come in here and play with it a little bit more. It doesn't look like there's anything in this commented out code that can't be called. I think, yeah, I'm not sure. I got to go into that a little bit more. But the check auto caution distance threshold, that's basically what the sensors do. So if the sensor detects that there's a vehicle in front of it, it's going to slow down and stop. And then the move logic is, for the most part, tossed in here. I couldn't bring a rigid body in here, so to calculate the speed, I actually just searched around Google a little bit and figured out how to actually get the magnitude of a vector 3 without using a rigid body. Just basic math. But I think in Unity, most people don't use the math functions as much because all of the components have this logic built into it, but you can't pass classes into a job system, so because the class has that function, you can't use that function. So we're kind of going backwards in a sense, where in the past, if like you would search the forum and you would say, how do you do this? They would tell you that there's a component or a class that you can call a method from. But the problem is those classes don't exist in the job system. They just cannot do it. So what ends up happening is we need to do more stuff like just figure out how to calculate the speed without referencing a rigid body's velocity magnitude. You actually have to know the math formula. And then once you put that in there, you just grab the transform position and the previous transform position. And that was basically everything that's been put into the job. The first job, I also have a wheel job, which basically just, this is really actually a small job. It's just updating the car wheel transform position and rotation. Really simple. This one is the car transform position. So I'm just assigning some data here, and I'm getting it from the car transform access array. So I'm taking advantage of the iJob parallel for transform. And that's what I've realized. For the most part, all of these jobs that I'm using are using iJob parallel for transform. That way I can iterate over transforms. I don't believe that there's a way to bring multiple transforms into a job. Anyway, and wheels are active. This was one that I'm actually not using yet. You can see it has 0 references. The reason I'm not using it, or the reason I built it, you can only do so much in a day, but My idea here is if the wheels are not visually active, then we don't need to do some logic that would update the wheels, like their position and rotation, because the player's never going to see those meshes. And like, so from the position that I previewed for you, we're doing a top-down view. All of the wheels are disabled by LOD at that point, and yeah, there's just really nothing else to do with the wheels. So what I need to do is in this method, in this job, I'm going to end up setting up some logic so that I can mark each vehicle's wheels as whether they're disabled or not. And then if they're disabled, then I won't execute the collider update logic, which would be referencing the collider to figure out what position and rotation the wheel should have at that point. And I think that would gain me a little bit more performance. So yeah, that's basically what the fixed update does. It goes in, and the first thing it does is it references whether or not the vehicles need to stop for traffic, and then it constructs all of the data, and then it creates a job and schedules it, and then it just calls complete. So then after that, it's basically we're going to operate on all of the results. So I have the operation on route progress. It's actually interesting. I commented these out as a test, and anyway, maybe that's just a sign that logic doesn't need to be there. But these two lines right here that are commented out shouldn't be commented out. But yeah, like I said, that's going into an expensive, it's going into the waypoint route list, and then the waypoint data list, and then it's grabbing the waypoint, and then it's calling trigger next waypoint. I should really just have a reference to that waypoint so I could call trigger next waypoint. But the fact that these are commented out right now, obviously maybe that logic just might not be necessary. So when I built the AI traffic system, what I did was I built a really generic AI car that was capable of doing a ton of things. And then after it was able to do that, I started taking it and trying to scale it up. And like I said before, what I realized was that I don't really need it to do that much. This is just a basic traffic simulation. So anyway, yeah, I just need to look into that logic tree a little bit more to figure out what's going on there with route progress, because that just might be some unnecessary calls in this for loop. So next, route logic, I actually changed it a little bit. None of these vehicles are changing lanes, and I think I'm going to leave it that way. I don't believe that I need these vehicles to change lanes for any reason for the game. And if I want to, I could come in and I could set up the logic for them to change lanes, but currently that's just commented out. So this was something that I couldn't put in the inside of a job, is the sensor logic. This is the physics box cast, and those are the volume sensors that I use. What I actually did with the sensors, so since they're not changing lanes, they don't need the left and the right volume sensors. They don't need to know if there's a vehicle on the left or right, because they're never going to change lanes. And also I just made it so they only had one forward sensor. So each vehicle basically only has one sensor right now that's calling boxcast. And that helped me gain a lot of performance. All of this logic right here, that was something that was just tossed into a job. So that was the route logic. And so check auto caution distance threshold. Inside of the jobs, we're basically just calculating the speed array and calculating whether or not we need to override input. And here, if we are overriding input, we're just calling into the rigid body and setting the drag and the angular drag. I still want to put another check in here so that I'm not calling into the rigid body like subsequently. Like if we're overriding a setting minimum drag, I don't think I need to do it over and over again if we're still in that state. So basically I just need to make this state based And the same thing for when we're setting regular drag, or setting drag back to normal. What I do with the drag is, so when the AI vehicle sensor detects a vehicle in front of it, that's basically how I slow it down. I just increase the drag until it slows. And then this is probably one of the most expensive parts, where I'm just referencing all of the wheel colliders and getting their world position and applying the steer angle, and then setting the wheel position for each of these. The position itself is actually assigned in the job, but this is, I think some of this stuff can still go into a job, but I need to look at this a little bit deeper. So that's move, and then after all of this is called, that's when those other jobs that I showed you up there. So the wheel job is actually used once for each wheel. So I create a front right wheel job, a front left wheel job, a back right wheel job, and a back left wheel job. Yeah, so that's basically it. And then I just complete all of the jobs as in sequence. And then on destroy, I'm just disposing all of the arrays, and that's basically it. So I think previously there was a lot more code than just 1,000 lines. So we're at 1,011 lines for this car AI job controller, and I think that it can still probably when I'm done, it'll be about 500 or 600 lines. Maybe I don't know if it'll be smaller, but once I'm done with it, I'll probably look into the job system a little bit more and see what other optimizations I can do. Basically, I'll start looking into what other people did with their job system. So hopefully what I've done with my job system for this AI car traffic system, and by me sharing what I started with and what the logic looked like and what the logic looks like now and what the results were, hopefully it helps some other people. Basically, I was at a point where I could have 100 AI vehicles, and now I have 700. So that's pretty awesome. Anyway, that's about it. If we go back to Unity, it looks like all of the intersections are blocked because I have poor traffic management and lots of cars. So if you're curious about that, that'll be solved by me basically setting some better timing on the traffic lights and just paying attention to what they're actually doing in the simulation, and then adjusting for that behavior. But anyway, I hope you enjoyed it, and I hope you learned something if you're interested in the new DOTS framework. I'm really excited about it. I think that just the little bit of work I've done over the last week is it really paid off more than I could have expected it to. And I feel like if I spend another week looking into ECS, I can probably easily have another 7 times what I have right now. So that being said, thanks for checking it out. I'll see you in the next video. Bye.